Hello everyone and welcome to the 8th tutorial in a series of video tutorials for Java programming. Don't forget to click on the subscribe button and click on the bell icon as well to stay up to date with every tutorial I upload on my channel. So in the last tutorial I discussed about all types of loops in detail with the help of the IDE. So in this tutorial, I'm going to be talking about literals and variables concept. So if you remember, we have already talked about the concept of literals. So we are going to be looking into it in a little bit more detail, and then we are going to look at the variables also. So let's get started. So first of all, we are going to talk about integer literals. Okay, so if you talk about integer literals, it can contain either a decimal value, or it can contain an octal value, or it can contain an hexadecimal value as well. So if I talk about decimal value, okay, decimal value means the base is 10. Okay, so the valid values are for 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that is the base is going to be 10, and that are the valid values in that. If you have studied digital electronics, then you would already know that what is the concept of decimal numbers, what is the octal number, and what is the hexadecimal number, and all those concepts. So decimal value means it is from 0 to 9, and base is going to be 10. If I talk about an octal value, okay, if I'm talking about an octal value, then the value is from 0 to 7. Okay, so that is the valid range, and base is going to be 8 in that case. And if I talk about hexadecimal value, okay, the base is going to be 16, 16, and in this a slightly different concept is followed. So from 1 to 9, from 0 to 9, we are going to simply use that. Then after that, instead of 10, we are going to write A, B, C, D, E, F like that. So that is a concept which we are going to use in that hexadecimal value. So when I use the ID, so it will be about 2 tutorials or 3 tutorials later. Then I will show you how exactly we can store an octal value in integer literal, and how we can store a hexadecimal value in an integer variable. Okay. So basically, if you have to declare a decimal value, if you have to store a decimal value in an integer variable, you don't need to do anything. You can simply write int I equals 23, and the in decimal value will get stored over there. However, if you want to, store octal value in an integer literal, then you need to, prefix the 0 in front of the value. And in such a case, you need to ensure that, the octal value is perfectly valid. You cannot write, 08 or 09 over there, because 09, it is not a valid octal value. Okay, as I said earlier, the range for octal value is from 0 to 7 only. So you cannot write 0 to 08 or 09. And as for the hexadecimal value, if you are defining a hexadecimal value, and if you are storing it in integer literal, then you need to write 0x, 0 this capital X. Then after that you can write the hexadecimal value. So we will look into this more detail when I go to that IDE, okay, IntelliJ IDEA. So now let us go to the next slide. So floating point literals. Okay, now one thing you should remember is that integer literals means I'm talking about all 4 types of data types which I discussed two tutorials ago. So I'm talking about int, okay, short, long, and byte. Okay, so you need to remember that. So then after that, floating point literals. Floating point literal means that floating point means basically what is the floating point, why we need floating point, why can't we simply just get away with the integer literals? The reason is because there are certain values which have fractional components. Like for example, if I talk about the value of pi, you know very well that pi is constant, and the variable is the pi is has a decimal value 3.141915 something. So for that reason only we need floating point literals. Okay. So now here, for the storing the decimal value which have fractional component in it. So that is when we need floating point literals. So now here what I'm doing 3.15f. In Java, there are always two types of data types. One is float and one is double. If you are talking about floating point data types, so in float, if you have to define a float, then we need to, you need to mandatorily write f after literal. Like here, I've written 3.15f. If I don't write this f, then the compiler, Java compiler, is going to assume that I have defined a double variable. However, if you have written this f, after the this number, it is going to assume that it is a float variable. So it is mandatory to write this. Okay, many novice students, what they do, novice programmers, they would simply write float, float f it is equal to 4.479 or something like that. They don't append the f. Then it will give an error. It will say you're trying to convert double to float, and that is not allowed in Java. You cannot convert double to float. However, you can convert float to double. So that concept we'll be discussing later in this tutorial itself. So if you need to just remember one thing. If you are trying to define a float variable, then you need to mandatorily write f, okay, after this number. However, if it is double value, then you don't need to write it. But if it is float, then you need to mandatorily write this f. So if I talk about Boolean literals is the very easiest concept in Java, because Boolean data type, it supports only two values, either true or false. It doesn't support anything else. So just keep this in mind. If I'm talking about Boolean variable, if I talk about Boolean literals, it is valid. Literal is only true or false. Nothing else is supported. As per Boolean is concerned. So now if I talk about character literals, okay, I think I already mentioned this in the couple of tutorials ago also. So if you talk about a character literal, a valid character literal, it is always mentioned in single quote. Okay, so here you can see A is in single quote. This is a lowercase a, this is a uppercase a, and all of them are in single quotes. And I also mentioned this that character literals, they can contain integer values as well. So here char c is 65. This 65, it is a kind of a character literal. So this 65, actually it is a ASCII code. I told you in the couple of slides, like this couple of tutorials ago. This 65, it is a ASCII code for a character, and that particular character is what gets stored in the variable c, which is declared here. So now if I talk about string literals, okay, if you talk about C or C++, string is implemented as an array of characters. If you are experienced C and C++ programmer, you will know that array is implemented as an array of characters. However, in Java, string is not an array of characters. However, string, it is an object type in Java. Okay, so string, what it is going to contain, it is going to contain sequence of characters in double quotes. So that day I gave the example of YouTube within double quotes. If you write YouTube, then that is going to be a string. Similarly, in double quotes, if I write Monday, then that is going to be a string. So now this string, as I said earlier, actually it is a class, predefined class, okay, which is defined in Java, and it has many methods. Unlike C or C++, it has many methods, and using these methods, you can do a lot of things. Like you can do concatenation, okay, you can do a lot of things. We'll be discussing them later on, but you need to remember that string, it is a kind of class in Java which is already defined by the Java developers. So now variable. Now, so till now we discussed about the literals. Now, what is a variable? Okay, if you want to store any kind of value in Java program, then you need to create a variable for that. Okay, so that is what a variable is. It is a kind of basic unit of storage. Okay, so now what is the identifier? That also already discussed. Identifier, it is a variable name, or it is a name of a particular variable. Okay, so here I have given certain examples. So let me just explain what are the examples about. So in the first statement, I am declaring three variables a, b, and c, and all of them are of integer types, int. Okay, I am doing nothing else here. In the second statement, what I'm doing, I'm declaring two variables. So one is d and one is e. Okay, and both of them are integer. But here there is a difference. Here I'm assigning the value 24 to the variable d. Okay, here I'm not initializing the any variable, but here I'm declaring as well as initializing the variable d. Here I am declaring the variable z, okay, and it is of data type byte, and I am initializing 22 to z. Similarly, here what I'm doing, I am declaring a variable named pi, okay, and it is of double data type, and I am initializing it. So all these three things are basically I'm declaring the variable. Okay, here I'm declaring it as byte. Here I'm declaring pi as a double data type. Here I'm declaring x as a character data type, and I am initializing all the values. Okay, so that is exactly what I'm doing in those five statements. So now this is all kind of static initialization. So what do I mean by static initialization is that I am assigning the values to the particular variable during compilation time. So before compilation, I am assigning the value 22 to this z. I am assigning 3.1415 to pi, and I'm assigning this x character to this x. Okay. So there is another concept known as dynamic initialization. So, now if you look at this statement, like double root, it is equal to math dot square root of 4. Now in Java, there is a, class, predefined class, okay, which is called as math, and that math, it is going to perform all math related operations, like it is going to calculate the square root, it is going to calculate the power, okay, then floor, ceiling, etc. Lot of functions are available in this particular class. So here what I'm doing, I'm calculating the square root of 4, and then I am storing the value in this root, and the return type of the square root, it is double. Okay, now why I'm calling it dynamic initialization is because this method call, it is not going to happen during compilation time. This method call, it is always going to happen during runtime only. So that is the reason why I'm calling it dynamic initialization. So dynamic means basically which happens during runtime. Static means which is happening during compilation time. So this is dynamic initialization because I am initializing a method call to a particular variable. Here, this particular function, okay, so how the code is going to execute? First of all, it is going to declare a variable named root, okay, of double data type. Then after that, at the same time, it is going to initialize this particular variable. So how this thing is going to work? First of all, it is going to call this function, okay, and after that, whatever the result is coming out of it, so obviously the result is going to be 2.0 because it is a double, so always that fractional part will be there in a double data type. So it is going to return 2.0, and that 2.0, it is going to get stored in root. Okay, so that is the dynamic initialization. First it is calling the function, and after that whatever the result comes out of it is going to store in the particular variable, and that is why it is called as dynamic initialization, because the value is assigned during runtime and not during compilation time. Now, this is a very, very important concept, which you need to know. Okay. Now, I have done programming twice. Means I've shown you the programming aspect of Java at least twice with the help of the IDE. Okay. So, you would have noticed one thing that, even in the last tutorial, if you noticed extremely carefully, okay, I did it knowingly only. I created two for loops, okay, and in both the for loops, the variable I used was I. If you don't remember that, you can go and rewatch it once again so that the concept will get extremely clear. So, I did it very knowingly. I knew it very well. Now, one thing you need to understand, okay, you cannot declare the same variable twice, but still it was valid. In the last tutorial I did it, and it did not the compiler did not complain. But why it did not complain? There is a reason for that. Okay, I knew it very well that it will not complain, and it did not complain. The reason for that is because the concept is scope of the particular variable. Okay, so that is what we are going to discuss in this particular slide. So there are two things which you need to keep in mind. First thing is, you cannot use a variable before declaring it first. Okay, that is the first thing. And there is a second thing which you need to remember, that what's the variable you're trying to declare, it has a scope. Okay, so now let us see what exactly the scope is all about. Okay, in Java, unlike C, like I think in C, you cannot declare the variables underneath the first line or second line. So in Java, you can declare the variable at any time. Okay, you can send the value at any time. Okay, so that is what I mentioned here. You can declare the variable at any time. Okay, then second thing is, whenever you're talking about a block in Java, okay, it is going to start with the opening brace and it is going to end with this closing brace. So this is the starting brace and this is going to be the ending brace. Okay, and there are two types of variables in Java. One is local variable and another is global variable. So local variable means those things which we define in a function, or those things which we are going to define in that particular block. So those are the local variables. And global variables are those which are which we define outside the function or outside the particular block. Okay, so that is the kind of global variable. So this thing will be more clear when we I will explain it through the help of the IDE. So then the local variables, even the parameters, whatever methods we are passing to the parameter, that is also a kind of local variable only. Okay. So, and those which are defining within block, that is also local variable only. Okay. And, even nested scope is also allowed. Nested block is also allowed. So, and, you know, the visibility of that particular variable, that is limited and that is confined to the scope, or it is confined to the block in which it is defined. So now let me just get back to that for loop which I defined yesterday. So yesterday in the last tutorial I defined the two for loops. Okay, and in both for loops I used the variable I, if you remember. Now that I in the first for loop, okay, it is visible only till the end of the for loop statement. So it is going to be visible only within the for block. Okay. As soon as the for statement is going to end, as soon as the compiler encounters the closing block of this for loop, okay, it is going to destroy that variable because it is no longer needed, because that is a local variable. And that is why I was able to create another variable which was named the same name as I. Okay, so basically in that program there were two variables named I, and the program did not throw any error because it is all because of the scope. Okay, so now one more concept which you need to remember is all about type conversion. Okay, so in Java, if you noticed, okay, if you experiment with Java programming, so what you will understand is that it is possible to assign int value to the long variable. So what I mean by this is that you can create a variable of data type long, and you can assign it an integer value, like I'm saying long I equals to 25. Okay, that is perfectly legal. It's not, the compiler is not going to throw any error. Then it is legal to assign float variable to double variable. You can even assign float to double. That is not going to throw any error. Why it is not throwing error, you need to understand the concept first. Now in the last tutorial I talked about the the range, I talked about the width of the particular data type. So long, it occupies it has the width of around 64 bits, and int it has the width of 32 bits. So it is possible to store 32-bit data in 64-bit because it is a very big size. It has a very large width. Obviously, if you now, even in real life, just imagine, even in real life, what you can do, you can fit a smaller vessel into a larger vessel, right? Instead, you can definitely fit a smaller vessel into a larger vessel, but you cannot fit a larger one into a smaller one. That is not going to work, na? So the same concept is being followed here. You can store 32-bit data in 64-bit. That's not going to throw any error. Okay, but if you try to store 64-bit data in 32-bit, then the compiler is going to complain. So that is the concept which is being followed here. Same concept. Here float has 32-bit, double as 64-bit. So you're trying to store 32-bit data in 64-bit, it is not going to throw any error. Now here, this is the most important statement, no automatic conversion from double to byte. Now why this is not allowed? If you remember, double is 64 bits, okay, byte is 8 bits only. That is why automatic conversion does not exist. Compiler doesn't know how to convert double to byte. So it is not going to allow you to do that. And automatic conversion, it is also called as implicit conversion. Okay, it is automatically going to convert a particular data type to some other data type. So, there is no automatic or there is no implicit conversion from int to character. So then after that, the last statement is that, character and Boolean, they are not compatible with each other. So we cannot store a Boolean variable in a character data type, and we cannot store a character data type in a Boolean data type. Okay. So this is a very important concept which you need to remember, because, what you will do is you will try to store, double variable in a float, and it is not going to work. Okay, however, if you store, a float value in a double data type, then that is going to work. Okay, so these are the certain rules, for Java's automatic conversion. Java can automatically convert one data type to another data type. So first of all, the two data types must be compatible. So I mean by that is that, you can convert between int, okay, you can convert int to long, okay, you can convert it to short also, but that can be done only using explicit conversion. And so that thing doesn't come inside here. So let me just say that you can convert a byte, you can convert the byte because it has just 8 bits, right? So you can convert the byte to, short, you can convert it to int, and you can convert it to long as well. So, and the source data type, it is smaller than destination source type. So, the source data type, like I said, na, if you're trying to store an integer data type into a long data type, so source data type is integer, and destination source type is going to be long. Okay, and the width of source data type, it is 32 bits if I talk about int, and if I talk about long, it is 64 bit. So that is why, you can store 32-bit and 64-bit. It is not going to throw any error, and that is how the Java's automatic conversion is going to come into the picture. So don't worry about it if it seems very complicated now. It will all be clear when I explain it with the help of the IDE. So then, so this is going to be the last slide in this particular tutorial. So you can also, convert type manually. So like for example, if you are trying to convert into byte, that is not going to work. Okay, it is not going to get converted automatically, but you can definitely, do it through explicit conversion. Explicit means you need to do it manually. Okay, and this automatic conversion, it is also called as widening cast. Okay, widening cast. And this manual type conversion, this is known as narrowing cast. Okay, so because what we are doing, we are trying to store, this 32-bit data into 8-bit variables. So that is why it is known as narrowing cast. We are making it smaller, right? So this is the explicit type conversion, and this is the syntax. First, we need to open this bracket parenthesis. Then we need to write the target data type name. We need to close that particular variable, particular parenthesis. Then after that, we need to write value. Okay. So this is the example which we are using here. Like for example, here I'm writing 257. Now, if you remember the last two tutorials ago, I discussed that the range of byte is from minus 128 to plus 127. Okay, so this 257, this is actually an integer. It is not a byte actually. So this 257, I'm trying to convert it to byte. So for that purpose, what I'm doing, I'm writing byte inside parenthesis, and this integer, it will get converted to byte, by this explicit conversion. So this is the syntax for the explicit conversion, and then the value will get stored in this particular data type. So the same concept I'm following here. This 5.423, this is actually a double data type. So I just told you, 3 or 4 slides ago, if you don't append f, it is going to be a double data type. and if you append f, it is going to be a float data type. So here I cannot store a double data type into a float directly, because I cannot store a 64-bit data into a 32-bit data. Okay, it cannot happen automatically. If I need to store it, then I need to use narrowing cache. I need to explicitly use this type conversion. So for that purpose, what I'm doing, I'm writing float in front of this particular variable. So as soon as I use this float, this double, it is converted to float, and then the value gets stored in this particular data type. So that is all about in this tutorial. So in the next tutorial, I'll be discussing about arrays also, and little bit of portion is left in this type conversion. So I'll be explaining about that also. So, so that's all for this tutorial. If you have any questions, then don't hesitate. Don't forget to post in the comment section below, and I will get back to you when I can. And so that's all for this tutorial. So if you like this tutorial, then don't forget to like, share, and subscribe. And I will see you in the next one. So till then, bye.